Hey guys, James here, and today we're going to learn how to predict products, and we're going to be doing that in the Chemistry 151-6 GLA. We're going to be going over problems 1A, 1B, 1C, and 2A, 2B, 2C, and 2D in the extra practice section. So the problems read, determine the phases of the following ionic compounds. In order to do this, you're going to have to look at a solubility chart, which your professor should be able to provide you with. If you don't have one, you can find some online. They look like this, and they're usually broken up into a soluble section and an insoluble section. Each of these ions may or may not have exceptions to the rule, and we'll be going over how to use this effectively shortly. And so let's just jump right into the problems. 1A, we have a calcium and an acetate, or a C2H3O2 part to this. If we go ahead and check the solubility chart, we can find acetate right here in the soluble section, and there are no exceptions to the rule, so no matter what this part bonds to, this anion, it will be soluble. So 1A is going to be aqueous, or you could call it soluble. For 1B, we have silver and sulfate. If we go to the chart, we see sulfate is right here in the soluble section, but sulfate has a lot of exceptions, so we'll go ahead and check these. When sulfate pairs with CaSr, BaAg, or Pb, the compound is insoluble. So going back to the problem, sulfate is bonded to Ag, which is one of the exceptions, which means that this compound is going to be insoluble, or we can call it a solid. Finally, for 1C, we're looking for Pb and Br. Here is Br. When it's bonded with Pb, the compound is insoluble. So once again, 1C is going to be a solid, or you can say it's insoluble. And that's how you do 1A through 1C. For part 2, we're going to be predicting the products for the following reactions, and we're also going to be stating what phase they're in. We also have to pay attention to the chemical reaction and make sure it's balanced. So for these problems, we're going to do a double displacement, and we're going to have the cation of the first compound bonding with the anion of the second one, and then we're going to have the cation of the second compound bonding with the anion of the first one. So this is going to make an AgSO4, and then the second product is going to be NaC2H3O2. Next, we'll look at the charges. Silver here has a +1 charge. Acetate has a -1 charge. Sulfate is a -2 charge, and sodium is a +1 charge. The overall charge over here on the right is 0, so this compound's completely happy the way it is. We don't have to put these charges up here. However, because sulfate has a -2 charge and silver only has a +1, in order to make the overall charge equal to 0, we're going to need 2 of those silver molecules there. Next, we just have to determine the phase of the products. So we'll go back to the solubility chart. Sulfate is bonded to silver, so once again that compound is going to be insoluble. So we'll call this a solid. And then, like in the previous problem, whenever acetate bonds to anything, it's going to be aqueous. So we can just go ahead and call this one aqueous. And that's how you do 2A. For 2B, we're going to do the same process where we're going to do a double displacement here. When hydroxide bonds to an H, it's going to make a water molecule, and so that's going to be one of the products. But first I'd like to write the barium bonding to the sulfate and then the water. That's just a personal preference. Let's go ahead and balance this out. Let's look at the charges. Hydroxide has a -1 charge. Barium has a +2 charge. Sulfate has a -2 charge. And hydrogen has a +1 charge. So we'll go ahead and mimic those charges over here. Barium's +2. This water molecule has a 0 charge on it, so we don't have to put anything there. And the barium sulfate also has an overall charge of 0, so we can get rid of those. Let's see. On the left side of the equation, we have a total of 4 hydrogens. And on the right side, we only have 2, so we're going to need to put a 2 out here in front of the H2O. Now we should have an equal number of oxygens on both sides as well. Let's see, we have 4 over here, 5, 6. And then we have 4, 5, 6 oxygens. So this reaction is now balanced. All we have to do is determine what state these are going to be in. H2O is always going to be in the liquid state. Let's just go back and check to see if barium sulfate is soluble or not. Right here we have sulfate, and it's bonding with barium right here, so that is going to be insoluble. So this is going to be a solid. That's how you do 2B. Next is 2C, another double displacement. Go ahead and write the charges on these. Cl has a -1, K is a +1. NO3 is a -1, and Ag is +1. So when we do the double displacement, because all these charges are the same, we're not going to have to add any coefficients to anything. We're just going to go ahead and say that these products will be AgCl plus KNO3. And everything is balanced already, so we just have to say what state these are going to be in. Let's take a look back and see where Cl is. Cl is soluble except for when it's bonded with silver, so that is going to be another solid. And now we just need to find nitrate. Nitrate is right here. It is soluble and it has no exceptions. So the KNO3 is going to be aqueous. That's part 2C. Next we'll look at 2D. We're going to do another double displacement. So we have Ba bonding to NO3. And then we have K bonding to Cl. Let's go ahead and look at the charges here. Cl is a -1 charge. Ba is a +2 charge. NO3 is a -1 charge. K is a +1 charge. So we'll go ahead and mimic those charges over here. +1, -1, -1, +2. In order to make the overall charge here equal to 0, we're going to need 2 of these NO3s. So we can go ahead and erase the charges now that those are all balanced. Now we just have to balance the equation. On the right side, we have 2 NO3s. And so what we'll have to do, and let me rewrite this so this doesn't get too messy. We're going to have to add a 2 right here in front of the KNO3 in order to balance out the NO3s over here. And because now we have 2 potassiums, I'm going to need to add a 2 over here on the product side. When we do that, we change the number of Cls we have to 2, but that's okay because we have 2 of them on the reactant side. So this is balanced. Now we just have to state what phase they're in. We'll go back and look at the solubility chart for NO3. It has no exceptions, so this product is going to be aqueous. And then we'll go back and look at the KCl. K is soluble, it has no exceptions. So that product will also be aqueous. And because those products are both aqueous, there's no solid formed when the reaction happens. We're going to go ahead and say that there is no reaction here. Thanks guys, I'll see you guys next time.